Look at three measures of central tendency. What are those three measures? Mean, median, low. Mean is? Average. Median is? Yep.
Organized from lowest to highest.
Lowest to highest. Yeah, that's right. And then mode is?
Most occurring.
Most occurring, most frequent. That's right. Okay. Today we're going to look at a new one. One that you haven't seen or heard of before. And this is what we call standard deviation. Now, in order to do standard deviation, on your calculator they have a symbol for it. It looks something like this. That was sideways 6. What standard deviation is it's how much the information that you have done varies from the actual mean, the average. Okay? So what happens here is that we calculate our average first. And then we want to find out. Now, we've also used range, which is your lowest to your highest. So if there's a big gap in them, all right, we can't tell where the information lies. Maybe there's a couple way on the outside, what we call outliers, or there might be a bunch on the outside, and then heavily involved in the middle. But standard deviation puts an actual number value on it. How much are you varying from the actual average? So if I took the class average of the class here on the last test, let's say, and let's say the class average was 70, all right? The standard deviation would tell us how many marks were within the range of 72 to 68. And then the standard deviation might tell us how many were in the range of 66 to 74. Okay, so the standard deviation tells me how many of the scores are close to the average. Now they use this in university on what we call a bell curve, which you're going to learn about tomorrow. So the bell curve, what it essentially does is it finds out how closely the data is to the average, and then they'll sometimes move it if there's a big gap. All right, and let's say the average was really low, but all of the scores were really close to it. They might move it up a standard deviation, and everybody would move up a certain percentage. Okay. So the first thing we need to do is we want to learn how to calculate what the standard deviation is. And there's a table that we set up, and then we go through a number of steps in which this happens. Now, a low standard deviation is a good thing. That means that all of our information is really close to the mean or the average. A high standard deviation means that we've got quite a range in data. That means that the scores are all over the board. Okay? To calculate standard deviation for a data set with n values, square the difference of each value. Okay, so the first thing that we're going to do is we're going to create a chart. The first thing on the chart is my actual scores. Okay? So X represents my actual scores on this chart. I'm going to use example 2 to do this on page 117. So my scores, somebody read those scores to me. 11,
13,
yeah,
14,
yeah,
15, 15, 16, 18, 14, 13, 14.
Thank you. Okay, so those are my actual scores. So the first thing that I want to do is I want to find out what the average is. Okay? The symbol for average in this case, or mean, is X with a line over it. That means that's your mean. That's your average. So I want you to total this up right now, and I want you to find out what the average is. So there's 10 scores there, and let's find out what the average of those 10 scores was. What is it?
14.3.
14.3. Okay, so I should back up a second. Let's look at the questions asking. Randall wants to adopt a cat from a local animal shelter. He's looking to adopt a Persian cat or a Burmese cat. He searched 10 different internet sites for the lifespan of each breed. His results are shown. So the average lifespan for a Persian cat is 14.3 years. Okay, so by researching the website, this is the number of years that the cats, what was the lowest number of years that the cats? 11, and the highest? 18, so your range would be? 7, okay? So we'd have to arrange them in lowest to highest to get out our medium. What's the most frequent? What's our mode? 14 or 15, right? They both occur twice. Okay.
14 3 times.
Oh, 3 times for 14. 1, 2, 3. You're right. So then the mode then is 14. Okay. So the next thing that we do.
What's that X with the hat mean?
Just explain that, Austin. That's my mean. It's my average. Okay. So, just gotta make sure I'm going back through this, make sure everything looks right. Okay, so the next thing I do, what does this X represent?
Which one?
That one right there?
The actual.
The actual score, and that is the average. So what is this whole thing asking me to do? Page?
Take the number that you have there and minus the average from it.
That's right. So that's the next thing that we do. We're going to take 11, we're going to subtract 14.3. 13, subtract 14.3, and so on. So let's do that. So 11 subtract 14.3, negative 3.3, right? And we have negative 1.3, negative 0.3. We have 0.7, 0.7, 1.7. Am I doing that right? 18 should be 3.7, I think, correct? Okay. Over there. Go over there, and then you can talk to me. Yes, it's so hard done, buddy.
Yeah, quite am.
Good start to your day, sir.
For the second last one, it says, or the last one says 0.7 should be negative 0.3.
What about, sir? Oh, right here, negative 0.3? Yeah. Thanks. Yeah, thank you. Okay, so now, what do you suppose I do in this column now?
Foil.
What's that?
Square the number you have before.
That's right. Okay, so I had the difference, that's this. Now what do? I just square it. So negative 3.3 squared. So 3.3 squared is?
Negative 10.8.
Should be a positive,
Oh.
right?
Oh yeah, 10.8.
Right? So these are all going to be positive values. Okay, 1.3 squared is 1.69. 0.3 should be 0.9, or no, 0.9.
How are you getting a positive?
If you square a negative number, what's negative 2 times negative 2?
4.
What is it? 4. So every time I square a negative number, I get a positive. Okay? So then this guy is 0.49, 0.49, 1.7 squared. Pardon me?
2.89.
2.89. 3.7 squared.
13.69.
Right? And about 0.09, 1.69, 0.09. Okay, so everybody understands the symbols then? Pretty straightforward so far. All right, X is your score. X the line over to mean. X subtract your mean, this value. X subtract your mean with that square. Okay, so the next order of business is this. Okay, so there's a new symbol for you. You haven't seen that before? That means sum. That means sum. Okay?
Some of what?
What do you think?
The number,
Which numbers?
In the column.
Mm-hmm. Yeah. So it's the sum of all that's in that column, basically, that's what it's saying, right? So we add all of these up. So let's do that right now. A couple of you or all of you do that so that I know we've got the right answer for it.
No, that's wrong. Just undo that.
Okay. Use your calculators and add those up, please.
32.1.
2 decimal places. So I got to use that number again.
Just gives us
Just one.
What does it? 32.10?
Yeah.
Perfect. So we've got more than one answer that concurs with that?
Yeah.
Okay. The next step then. So that's that number, right? And what do I do to it?
17.
Divide by n. N is the total number of scores that I have entered in, which in this case is what? 10. So this will be
Oh, it's N. I thought that was 7.
same n. See how it looks like the 7 and the 1, but right. So I've got 3.210.
Yeah.
All right. My last step then is this. So what do I have to do now? Square root 3.210. And what do I get?
1.79.
There's my standard deviation. Okay.
Wow.
All right.
So are you filling numbers in for the sum and for the x's or not?
That's awesome.
I don't understand your question.
Like the 32.10 is the sum, which is that funky e thingy, right?
Yes.
So, but you're disregarding the x's and the squared?
This is the sum of all of that. What is all of that? That column.
So you're not like multiplying or nothing?
No, I want the sum of this. Well, this is this column. So I'm adding all of these together. Does that answer your question or not?
Yeah.
All right, this is not sum times this. This is telling you, take the sum of that column. Once you have the sum of that column, divide it by the total number that you have. Once you divide it, take the square root of it. Okay? All right, so this is, I just want to see where this goes next. I'll give you an example.
Whoa.
All right, so I want to explain what standard deviation is. This is hard for us to comprehend because it's something that's completely different than what you've done. So I want to explain it to you in a way that it may make some sort of sense to you. And I'm jumping ahead into 5.4 in order to 5.4 and 5.5 in order to do this. But here's what happens. I explained this to you. A normal distribution of data. Okay, so you were working with histograms and frequency polygons yesterday. A normal distribution of data, if it's normally distributed, meaning it's evenly distributed, it should have a shape that in which your histogram graph kind of builds up into the middle and then works its way back down. So it kind of has this shape to it. So when I say it's normally distributed, it means it's evenly distributed on the half of the middle is going to represent my mean average. okay? And half of the information that I have is going to be on this side of it, and half the information that I have is going to be on that side of it. So that means that, and it should make sense, half the scores in the class should be below the average, and half the scores in the class should be above the average, if that's what the average actually is, right? This is what we call normally distributed, okay? So the mean is the middle of this curve right here. I then divide it into sections. So don't write this down, but I divide it into sections. There's section 1, here's section 2, and here's section 3. There's 3 over here, 1 here, 2 here, and 3 there. So I've divided this into 3 sections on the right, above the line, 3 sections on the left, below the average. Now what's the point? The point is this. If I redo this without the histogram in there, I draw my average right here, my mean. I'm going to say that my mean for a test was 70%. Okay, so I'm going to make this make sense. My mean for my test is 70%. This is 1 standard deviation above the mean. So 1 standard deviation above the mean. Now let's say that we calculated our standard deviation. We took the test scores of this class and we calculated our standard deviation, and let's say that our standard deviation was 3%. That means that 1 standard deviation above is 73%. 2 standard deviations above, 76%, and 3 standard deviations above is 79%. 1 standard deviation below it is 67%. 2 standard deviations below, 64, and 3 standard deviations below, 61. Okay, so what does this tell us? Well, it tells us that the majority of the test scores in this class were between 61 and 79%. Now that's not saying that there can't be a score bigger or smaller than that. That is a possibility. But the majority of the scores. Now what this bell curve tells us is it actually tells us the percentage of scores that this occurs. All right? Within 1 standard deviation above and below, 34% of the scores will end up in there. Now you're going to hear a lot of percentages. We're going to use that word a lot. But here's what this says. Okay? Between the scores of 67 and 73, 68% of your class scored between 67 and 73%. That means if there's 100 of you writing this test, and our average for the 100 of you was 70, that means 68 of those scores fell between 67 and 73%. Okay? 50% of the scores were above 70. 50% of the scores were below 70. And then it goes into giving us the percentages for this and this and this and this. And now what that does is it tells us how many of the people in the class scored in that area. In between 70 and 73, or 70 and 76, depending on what we're looking for. So in the question that we just did, the average life expectancy for a cat, a Burmese cat, was 14.3. Agreed? Mm-hmm. We calculated, we'll change that to 1.8. We calculated a standard deviation to 1.8. Therefore, if I add 1.8 to 14.3, what do I get? 16.1. And I add 1.8 right here. 17.9. And I add 1.8 right here. Okay. So according to what I just put on the board here, I'm just going to flip ahead. I got to make sure I got my percentages down properly. 13.5%. 13.5%. And then I have 2.35%. This is 0.15. Okay. So I want to explain this question to you. It says that a Burmese cat between 14.3 years and 16.1 years, 34% of the Burmese cats are going to survive between 14.3 and 16.1 years.
Are you just making these numbers up?
These are given to you.
The percentages?
These percentages are given to
Look
you.
on 5.4.
In a normal distribution, in a bell curve, these percentages are always standard. Okay? So if your information works it as the bell curve does, it gives you that. So if I go 1.8, subtract that, I'm going to get 12.5. Subtract that, it's going to give me 10.7. Subtract that, it's going to give me 8.9, I think. Okay? So now, what that says is this. If I asked you, what percentage of cats, Burmese cats, are going to live between 14.3 and 16.1 years, you can say 34% of them will. If I asked you, how many of those Burmese cats are going to live between 12.5 and 14.3 years, you're going to say 34% of them will. If I said, how many of those Burmese cats are going to live longer than 14.3 years?
50%.
50%. How many of those Burmese cats are going to live less than 14.3 years? 50%. How many of those cats will live longer than 17.9 years?
0.15.
2.25 plus 2.0.
Yes, which is 2.5. You're right. How many are going to live longer than this? 2.35 plus 0.15, which is 2.5. So standard deviation, what we learned right now on how to do it, the reason we're doing it is it tells us a certain percentage of the data where it's going to fall underneath. Now, where else would I use this? I might use this on the life expectancy of batteries. If I was comparing batteries and I wanted to find out with batteries, which one is the best battery? I might use this curve based on the life expectancy of the battery. And that would tell us which one is going to last the longest, but it might tell us what is the percentage that they're going to last a certain length of time. Okay? So we use this for test scores. We use this for life expectancies. Those are a couple of things that we use this for. Will you use it? Probably not. But if you go to university and a prof marks on a bell curve, you may use it. All right? So what we have to have done here is this is your steps. This is what you just wrote down. You need to be able to calculate from a group of data, anywhere from 10 to 16 or 20 pieces of information. We need to be able to calculate what the standard deviation is without the use of the calculator. All right? Now I'm going to show you, this is why I said this. If you want to do this successfully and quickly, if you have the graphing calculator, this is an easy thing to do. But you need the graphing calculator to do it. On the other calculators, some of you will have a statistics mode. You can do it, but it's hard to find out if you've made errors. So that's where we're at. Okay, so this should have been taken down. This will have to go on your cheat sheet. All right, so make sure that you have that down. Okay, so let's try one more example.
Question.
Sure.
Can you go back to the graph? Like this one? when you're doing your standard deviation or whatever,
Deviation, yeah.
and you do +1, like, what does that mean? 'Cause you just,
That means one standard deviation above, so add one standard deviation, depending on what that percentage, or what that number is. So in this case, my standard deviation,
or 1.8.
I had that wrong there. My standard deviation was 1.8, right?
Yeah.
So one standard deviation is add that to the mean,
Mhm.
that's one standard deviation above. Add it one more time, that's two standard deviations above,
Oh.
okay? Well, this should be a plus two.
Yeah. I'm confused as like,
Okay,
Yeah, that's cool.
alright. Okay, let's try this again. Go for it on here. Here's your X. So supervisor records how many, so Nico lays patio stones, the supervisor records how many he lays for 6 hours. Calculate Nico's mean and standard deviation. So 6 pieces of data. Go ahead and find that out. Fill out your chart. What do we get as the average?
39.
Okay, so we'll leave it as 39.3. Everybody get the sum of the
Not yet.
squared values?
Yeah, 67.3357.
67 point.
3357. Oh, did we shoot that up?
Do you mind? Would you get on out 65? Sorry. I got 66, but I have 34.
We both have been asking. Three grades is 7.24.
I know, but I have 3, 3, 4.
Well, no.
It'll depend on what you did to subtract these.
Yeah,
I
did.
did the 3. Oh, I didn't. That's fine.
Okay, let's do it like this. I'll fill it in with you for right now. Okay, so what is this one here?
Negative 5.3.
5.3? Here? Here? Do I get that same answer?
5.7.
Yeah, yeah.
You
got 5.7.
And then for the 1.7, I go
I got
1.67.
5.7.
So 5.7 there,
For 1.7, I got 1.67.
Oh, I-
1.67?
That's just,
Oh,
it's close.
That's rounded.
Oh,
Are we okay? Does everybody got that column right now?
Yes.
Excellent. Okay, so then that squared is
28.09.
2.89.
2.49.
1.69. 1.49.
32.15.
49.
I got
My numbers are different than theirs as well, because I did like more than just
All
one
my
decimal
numbers
place on the
are
first one. So my
Okay.
numbers are kind of.
So
32.45.
this is 32.49, is it not?
Yeah.
Okay. All right. Now we add those together.
67.34.
What'd you get, sorry?
67.34.
Okay. Divide that value by 6.
11.22.
Square root it.
3.35.
And voila.
Are you ever gonna make us put that into a graph?
No. I have one more chart that I'm going to show you, but I won't show you till tomorrow. I'll show you the chart tomorrow that deals with frequency. I just wanted you to start with this today. Any other questions about this guy today? No? Are we okay? It's just steps. Just steps. Follow it through. All right? But we have to nail this down because tomorrow I'm going to give you one that's a frequency table, and it'll be another 2 or 3 steps that we have to incorporate into this. Okay?
Can can you switch like the paper thing to the notes? Like,
Yeah,
step by
like,
step
yeah.
notes, okay.
I'll come back to it. I want to erase this off of here, so. All right. Any trouble with yesterday's work? Have a look at yesterday's work. I imagine most of you are not done.
That's not that right.
What kind of attitude's gonna get you homework?
Sorry.
Okay. So you should be able to finish 5.2 for tomorrow. With the rest of today to do it. Another 30 minutes to do that. Okay. You need that left on there, girls?
Yeah.
Yeah.
Okay. That's what you wanted right there, just that screen, right?
Yeah.
Okay, work on 5.2 this morning. Finish it up.
Oh.